I think you can see the screen, isn't it? Screen I have shared.
Yes, sir.
Oh,
Yes, sir.
fine. It's good. Just wait a minute. I need NCERT part 2. Oh, yes, part 2. Okay, good. Good. Good evening. Hello everyone. This session I will be discussing conditional probability. Probability for class 12. Probability for JEE Main and Advanced. What is the difference? Class 11 and 12 syllabus both will be there in JEE Main or in Advanced. JEE Main in accordance with the CBSE syllabus. So you should learn the topic NCERT exemplar based problems properly, and then you go for solving JEE Main or advanced type problems. So this class I am going to explain the concept of probability from class 12 syllabus, whatever there in CBSE board examination course. Okay. So this we can start, but I'll tell you, you have to remember the formula and the concept you have learned in class 11 course. Okay. In class 11 you have done a lot in probability. There is basic concept of probability you got there, and I'm not going to discuss the basic probability here, but I remind you these kind of formulas. Probability of an event always greater than equal to 0, less than equal to 1. Hope you all remember it. And number 2, probability of the event A plus probability of complementary event is equal to 1. And number 3, for two mutually exclusive, I am writing ME events, for two mutually exclusive events A and B, P A union B equal to PA plus PB minus PA intersection B. And no, for mutually, this is in general, for any two events, A and B, we have this thing, PA union B equal to PA plus PB minus PA intersection B. For ME events, mutually exclusive events, there is no common point between them. A intersection B equal to phi. So PA union B going to be equal to PA plus PB. Okay. PA union B will be PA plus PB for mutually exclusive events. What happens for three events, that also will recap once, that probability of A union B union C is nothing but PA, PB this minus PA intersection B, PB intersection C, this plus PA intersection B intersection C. All these you did. And one additional formula, that PA minus B we can write as PA minus PA intersection B. This all you have studied in class 11 syllabus only. Class 12 we are going to start with the concept of conditional probability. Okay? I'll give you several examples, but before that I tell you today's discussion will be on the curriculum syllabus given for CBSE board examination 2025. Okay, I think it will be continued for next few years because just recently the syllabus is changed. So we mainly focus on the topic covered in the syllabus, given syllabus. Not whole of it we can cover, but the first part, conditional probability and Bayes theorem, I will be doing with you. What is conditional probability? Definition wise, conditional probability is the probability of an event occurring given that another event has already occurred. It is denoted by PA by B, which reads as probability of A given B. Given B means probability of event B is given. Okay. What is that? Let me consider one example here on it. Let us take an example here. Let a coin be tossed thrice. Okay, you know the sample space. I am writing to simplify the problem. There may be head on all three trials. There may be head, head, tail, tail, head, 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 tail, head, tail, tail, head, head, tail, 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 head, tail, and then tail, tail, tail. Okay? You know, a subset of this sample space is an event. It consists of elementary events, but that a subset can be considered as an event. Let us take A as an event. Let A equal to this event, say getting head twice. This event we are writing as getting heads twice. How will I write? HHT, THH, then HTH. You know it very well. Suppose B denotes the event getting at least one head. B denotes the event getting at least one head. Then B will be written as at least one head means HTT, THT, TTH, HHT, THH, HTH and HHH. Alright? Getting at least one head, this is the case. Now, these two events, there are some common points. Am I correct? There are some common points. What are the common points? That you can write by using the operation of events as what? We can write it as A intersection B. What is A intersection B? Let me write it first. A intersection B consists of these three events: H, HT, THH, HTH. Okay? HTH. Now, so one change I am making here, writing getting head at least twice. Okay, then this will include just one. Wait a minute, just let me change this part only. Getting heads at most twice, not more. I have taken two heads over there. At most means there may be head once, tail. At most twice. Just a minute. At most twice. There may be tail, head, tail. There may be tail, head. There may be all three tails. Okay? So the event I am taking this manner, getting heads at most twice, and here B getting at least one head. Then the common event among these two is going to be this thing, that HHT, THH, HTH, and more events are there. That is HTT, THT, TTH. What I am doing there? I am just writing A intersection B. Now follow this definition. A by B stands for what? Probability of the event A when B has already occurred. Okay, this is the meaning of conditional probability. So this is going to be number of favorable cases when we consider both the events are there. We are writing probability here in A intersection B, that divide by A when B has already occurred, and that divide by number of cases when B occurred. Now in this formulation, this probability definition, the original definition of probability I have used number of favorable cases by total number of outcomes. This is nothing but in A intersection B by NS in B divided by NS. NS stands for what? Total number of points in the sample space. A in A intersection B by NS. This is what? This is P A intersection B, and this part is PB. So actually P intersection B, this thing is now have this formula, that is P A intersection B by PB. Hope you have understood. Probability of the event A when B has already occurred is given by this. P A intersection B, that divided by PB. Okay. So let us account for this in the present problem. What we have taken there? A is the case when we are getting heads at most twice. This we have taken A and I have written all. B is the case getting at least one head. Then A intersection B, these 6 cases are there. And now if you want to write, P A by B, that is what? Probability of getting heads at most twice, given heads we got at least once. Under this condition, P A intersection B will be P A intersection B by PB. P A intersection B, how many cases are there? 6 cases. Total number of cases 8. And PB, how many cases? 7 cases. So this is going to be 6 by 7. This is the probability of getting heads at most twice, given we are getting head at least once. Okay, is that clear? If it is not clear, let us take more examples based on it. Formulation I told you, P A by B is this formula, that P A by B is P A intersection B. We will be taking the common part. This is the probability of both the event occurring, I mean intersection part. P A and PB are probability of occurrence of the event A and the event B. Now let us go for example 1. Okay. Suppose you have a deck of 52 cards. What is the probability of drawing an ace given that the card drawn is a spade? This is a very simple problem. Very good application of conditional probability is there. Let us solve it. Suppose you have a deck of 52 cards. Probability of getting an ace, let E1 or E simply denote the event drawing an ace. E denote the event drawing an ace. You know how many cases are there? How many cases are there? You know very well. 4 types of aces are there. Okay, that you can consider. Those aces are there, no, among cards. 4 aces are there. 2 black aces and 2 red aces. That is spades, clubs, hearts and diamond. Any, let me write. Any is 4 and you can write P also. P is 4 by 52. Card drawn is a spade. This is the event F. F stands for what? Drawing a spade. How many cases will be there in F? Spade 13. So this will be 13, and probability of F only, if you count, it will be 13 by 52. But our aim is to get drawing an ace given that it is a spade. So in the language of set theory, we are going to find E intersection F. Drawing an ace given that it is a spade. Drawing an ace given that it is a spade. So it will be actually the ace of spade, just one case. So this is going to be, I am writing in word, that is ace of spade. How many cases will be there? This case will be 1 only, because ace of spade is 1. What is the probability of drawing an ace given that the card drawn is spade? This was the question, isn't it? So we need to find n e by f. This is nothing but n e intersection f by nf. N a intersection, sorry, we are writing probability here, not number. By mistake also you cannot do this. So it is probability we are getting. P E intersection F by PF. I will be sharing all the problem sheets with you. Okay, all the problems with you. Don't worry. Those who are doing the class, do the problem with me. If you don't get, you ask me, I'll upload in my website. So P E intersection F is going to be what? This is 1 by 52 because one case only there, and PF we got here. So the probability is 1 by 13. Some of you have arguments with me that why not? This we are writing just NE intersection F by NF. My request, please don't do it in board paper. Board paper, go by this definition. Okay? NE intersection F by NF will give you the same answer, but you will be writing in terms of probability. So probability is 1 by 13 in this case. Go for next example. In a class of, just a minute. Yeah. In a class of 30 students, just read the sum. 18 are girls and 12 are boys. If 5 girls and 3 boys are left-handed, what is the probability that a randomly selected left-handed student is a girl? We will be following the same manner. Okay? "18 girls, 12 boys, 5 girls and 3 boys are left-handed. Randomly selected left-handed student is a girl." So first you have to write, let E be the event. The student is left-handed. Left-handed student is selected. Okay? F denote the event that selected student is a girl. This denote the event that selected student is a girl. So we are going to find P E by F, which is nothing but P intersection F by PF. Got it? P E intersection F. It means that she is a girl student. She is left-handed and she is a girl student. So left-handed girl student, how many? 5. So E intersection F, in E intersection F is going to be 5. So this probability will be 5 by 30. And PF, only F, how many? F stands for left-handed student is a girl. 18 girls are there. So this will be 18 by 30. 5 by 18. Clear? Hope you have understood basic concept of conditional probability. It is actually probability of joint occurrence of two events divided by probability of the second event. Clear? So we got P intersection F by PF here. Let us go for the next topic, total probability. Let me explain this part, then we will go for solving problems on it. What is total probability? This I am going to explain. Total probability Bayes theorem actually will come later. Let me do this thing on multiplication law of probability. Let me do it first, then we will go for total probability. Let us do it first. Multiplication theorem of probability states that probability of the intersection of two events A and B is the product of probability of A and the conditional probability of B by A. I explain what. This is actually probability of joint occurrence of two events P A intersection B. Probability of joint occurrence of two events, you have basic idea. Class 11 you did it in terms of the formula PA union B equal to PA plus PB minus PA intersection B. Okay. Now for PA intersection B in this class 12 syllabus, we have another way to learn. That is what? We have got P A by B conditional probability of the event A when B has occurred is, we have just done. Somebody writes conditional probability of B when A has occurred, P A intersection B by P A. Alright. Now you see in this formula, P A intersection B is visible. Here we can write this as what? We can write this as P A intersection B equal to P A into P B by A. Here what can you write? P A intersection B equal to PB P A by B. Alright? Clear? So if somebody finds PB by A or PA by B, then can find PA intersection B either by this formula or by this formula. If you have written PB first, then PA by B. If you have written PA first, it will be PB by A. Isn't it? So let me give you one example here, one simple example. That is, suppose an urn contains two white and three red balls. Okay? Balls are drawn one by one without replacement. Balls are drawn without replacement. Okay? I am writing two balls are drawn. Two balls are drawn without replacement. Find the probability that number 1 both white and number 2 one white one red. Okay? Both white means first row white, second row also white. We have to solve it with the help of the formula I have given there. I am writing both white as events W1 and W2. Those are events. White red, I will take white and red. So we are going to find P W1 intersection W2. Clear? This will be what? I told you, either you use P A by B formula or P B by A formula. So you write, suppose we have taken first one white, second one also white, under the condition that first one white from this urn, probability of first one white is what? 2 by 5, and second one also white when first one is white. So after one white ball taken, W taken, one white taken, what is remaining over there? One white, 3 red. So we are going to find P. What? Tell how to find it. You are taking the white ball out of 4. So answer is 1 by 4, 2 by 20. This is 1 by 20. Is that clear? I think you can see my board properly. It's okay. So probability of both white can be found by this formula. Now next one, we are going to find probability of white intersection red. So it will be P white, P red by white. P white, what's the probability? 2 by 5. P red, when one white taken, then 3 red and 1 white left, probability will be 3 by 4. So answer is 3 by 10. Clear? The answer is 3 by 10. P white intersection red will be 3 by 10. Clear? Understood? This is the conditional probability multiplication rule we can do. And even this problem I told you, balls are drawn without replacement. Even students are confused normally. What will happen if we draw balls with replacement? Will it change? Probability definitely going to change, but this formula will remain the same. Let us solve the same problem. 2 white, 3 red ball and getting 1 white, 1 red with replacement. Okay, same problem we are going to solve. Problem 2 here on it. Balls are drawn with replacement. Solve the above problem. Solve the above problem if balls are drawn with replacement. Same situation we are taking, that 2 white, 3 red, and what is the probability of getting both white, and what is the probability of getting, you have to find this thing, and number 2 probability of getting a white and then a red. This we are going to find with replacement. So we will use the multiplication rule again, solving it here. We have to write PW1, W2, first one white, second one white, under the condition first one taken white. Clear? First one white, what's the probability? 2 by 5. Isn't it? Second one white, You returned it back. So it will remain 2 by 5 only, that is 4 by 25. Am I clear? Understood? So PW1 intersection W2, I mean joint occurrence of two events is 4 by 25. Let us do this one. First one white, second one red. Writing this manner. P white, P R by white. P white, what's the probability? 2 by 5, and because you have returned it back, white you have taken, you have seen the color and then you will return it back. That's why it will be 3 by 5. Answer is 6 by 25. Clear? So PW1, W2 and PWR both are found out. Clear? Let us go for this example which I have kept ready for you, and let us solve it. Probability of raining today is 0.3, probability of carrying an umbrella is 0.8. I kept answer also, no answer is required. What is the probability that it rains and you carry an umbrella? Or this one. Probability of selecting a red ball is 0.5. Probability that a blue ball, given that a red ball had already taken 0.2. What is the probability of selecting a red and blue ball? Let us solve it, both the sums. How to? Probability of raining today is 0.3. So probability of rain 0.3. Probability of carrying umbrella is 0.8. Okay, that it rains. What does it mean? Given that it rains, so U by R given here. Don't write U only. It is U by R. Probability of carrying umbrella given that it rains. Then P U by R. Okay. Probability that it rains and you carry an umbrella. You find rain intersection umbrella. This is PR multiplied by P U by R. PR is what? 0.3, 0.8. Answer is 0.24. Clear? Understood? Read the statement and solve accordingly. Hope you have understood. Raining 0.3. Carrying an umbrella, it rains 0.8. What is the probability that it rains and you carry an umbrella? So this joint occurrence. Let us go for next one. Probability of selecting a red ball from a bag is 0.5. And probability of selecting blue ball given the red ball. See, similar statement. These are easier than the sum we have taken earlier. Because statement is so easy here. Probability of red ball 0.5. Selecting blue ball given that red is 0.2. To find the probability of P PR multiplied by PB by R. PR is 0.5, 0.2, this is 0.1. Clear? Hope you have understood. Just read the statement and proceed accordingly. So 3 different types of sums I have solved here. Now I am going to discuss independent events. What is that? Events, independent. We have studied mutually exclusive. We have studied exhaustive events also. But independent events, what is the meaning of it? Independent, literal meaning is what you think? Our country independent. We don't depend on British people nowadays. Isn't it? Our country is now independent. We don't depend on British people. Clear? So two events A and B independent if occurrence of one not dependent on the other. Two events A and B are independent if occurrence of one does not affect the occurrence of the other. So can't I say that if A and B two events involved, that for two independent events P A by B is equal to PA. Somebody says that P B by A, this will be what? This will be equal to PB. Clear? So two events A and B are independent if the occurrence of one does not affect the occurrence of other, means this thing. PA by B will be PA and PB by A will be PB. Clear? Now we know the formula of product rule. PAB is what? PA into PB by A. But for independent events, what have we got? For independent events, you got PB by A equal to PB. You got this? So therefore PAB going to be what? PA into PB. So this is the case of independent events. This is multiplication rule. You can say that multiplication rule is being developed gradually, step by step, one by one. Okay? So PAB equal to PA into PB. Events are independent. I give you one example here. This is a very simple example, you will understand better. Example 1. This is a dice is rolled and a coin is tossed. Writing here, dice is rolled and a coin is tossed. Find the probability of getting a head and a head on coin, obviously, and a multiple of 3 on the dice. What is that? Dice is rolled and a coin is tossed. Find the probability of getting a head and a multiple of 3. So what you are getting in coin is independent of getting something in the dice. Am I correct? Coin will show you head or tail. Dice will show you what? Dice will show you 1 or 2 or 3 or 4 or 5 or 6. So if you want to find a head and a multiple of 3, this is going to be, I am writing just this way. I am writing just this way. Let A denote the event getting a head. Okay? A denote the event getting a head and B denote the event getting a multiple of 3. So you write PA, getting ahead. That PA, getting ahead, will be 1 by 2, you know, and getting a multiple of 3. 1, 2, 3, 4, 5, 6. Getting a multiple of 3, how many cases will be there? 2 cases. Clear? 3 and 6. So PB will be what? 2 by 6. This is 1/3. So joint occurrence of 2 will be PA into PB. 1 by 2 into 1/3. Hope you have understood. This is the case of independent events, and given by PA intersection B equal to PA into PB, that is 1 by 6. Let us do this one. Rolling a die, flipping a coin, probability of rolling a 4 and getting a head. Similar way. Getting a 4, what's the probability? Getting a 4. Getting a 4, you take the event A. Getting a 4. And B denote the event getting heads. Getting heads, no, getting a head, isn't it? There will be one head only, no? Because you have tested one coin and one dice. So probability of A intersection B is required here, or joint occurrence of 2. This is again PA into PB. You understand simple sums only. Solve some simple problems yourself, then go for solving difficult sums. Getting ahead, probability will be 1 by 6. Getting a 4, sorry. Getting a head, probability will be 1 by 2. Answer is 1 by 12. Simple question. Go for next one. Drawing a card from a deck and rolling a die. Probability of drawing a king and rolling a 6. This you have to find. Similar question. I am just using this symbol. Drawing a card from deck and rolling a die. Drawing a king, that is PK, and rolling a 6. That I am denoting by A. A means S. S means for die is what? 6, getting a 6. So this thing will be PK multiplied by PA. King, what's the probability there? Drawing a king. King probability will be 4 by 52. And yes, they are independent event, no? Dice is rolled and from deck of card, one card is drawn. They are independent events. So PA will be what? That drawing a card from the deck and rolling a dice, getting a 6, only one case. So 4, 13, 1 by 17. Very simple example. Understand simple examples only before you do something very complex. Hope you are understanding with me. Go for next one. So this I am going to discuss now. These questions are based on total probability. Let me explain what is total probability. Now, suppose this event A occurs let A occurs when any one of the mutually exclusive and exhaustive events B1, B2, Bn occurs. Let A occurs when any one of the mutually exclusive and exhaustive events B1, B2, Bn occurs. Okay? A occurs when any one of the mutually exclusive and exhaustive events B1, B2, Bn occurs. Let all these are known, PB1, PB2, PBn are known. Then, and also you know P A by B1, P A by B2, P A by Bn. Got it? I'll give you an example. Just understand the theory here. Event A occurs when any one of the mutually exclusive and exhaustive event B1, B2, Bn occurs. We know probability of these events. We know conditional probabilities of these events. Then P Bi by A will be P A by Bi, this divided by PA. Okay? Conditional probability of ith event. Ith event is included over there. Then P Bi by A will be P A by Bi into P Bi, that divided by PA. This is known as Bayes theorem. Okay? Where PA equal to, PA means event has to occur. PA means event A has to occur, where PA equal to, it occurs if B1, B2, Bn, any one of them occur. So, probability of event B1 when A by B1 true. And this is the case where any one of the event can occur. Any one of the event B1, B2, Bn can occur. So we cannot stop here. It can be occurrence of the event A can be via this one, can be via this one, can be via this one. Okay? So PA will be PB1, PA by B1 plus PA by B2 plus PBn PA by Bn. I explain again. And this thing, if you have said this one Bayes theorem, this thing you will remember as total probability. Once more I explain. Okay? What we are going to do there. Then I will take one simple example. Then I will explain. Once more. Let the event A occurs when any one of the mutually exclusive and exhaustive events these events are mutually exclusive and exhaustive in the language of set theory. Okay? This is say B1, B2, B3, this is Bi, and this is Bn. Okay? These are mutually exclusive and exhaustive. They don't have anything common. They are not sharing anything among themselves. We know probability of occurrence of these events. We know conditional probability of A when B1, B2, Bn occur, that we know. Then what is the probability of an arbitrary event Bi here? Bi lies here only. When A has occurred, this we want to find. That we find by this form, this formula, and this you see P Bi by A. I have just taken opposite Pa by Bi multiplied by Pbi and divided by Pa. This Pa going to be sum of these events. Pb1, Pa by B1, Pb2, Pa by B2, like this. This is called total probability. Let me explain with example what is total probability and what is Bayes theorem. This formula only you keep in your mind. Setting one example here, one simple example. B1 and B2 I am taking two cases only. In case of B1, B2 I am taking earn 1 and earn 2. Okay? This one contain 2 white, 3 red, and this one contain say 4 white and 2 red. Wait a minute. 4 white and 6 red. Just let me change a bit. Why this change is required? Because I want to consider a general case. And I want to find symmetry is there by taking two events only. 3 white and 7 red. Clear? Question is given, one of the urn chosen randomly and a ball is drawn from it. I am writing the question. One of the urn is chosen randomly and a ball is drawn from it. Okay? One of the unchosen. There is a choice here. You can choose any one. Find the probability of getting getting a red ball. One of the unchosen randomly and a ball is drawn from it. Find the probability that getting a red ball. Probability of getting a red ball. What is the relation with this thing? Pa equal to Pb1, Pa by B1, Pb2, Pa by B2. What are B1, B2? What are B1, B2 here? Now that B1 and B2 replaced by earn1 and earn2. Okay? This is earn1 will represent B1, earn2 actually B2. And what you are going to find? You are going to find probability of red ball. Okay? Go by this. Pb1, Pa by B1. So write P earn 1 and probability of red from earn 1. Clear? This plus earn 2. This is a common sense also. Formula also has some common meaning. When you are selecting one of the earn and choosing a ball from there, it may be first, may be second. First one, this case, red from there. Second one, this case, red from there. So, Probability of getting earn 1 is half. Out of 2 you are selecting 1. Probability of rate from it 3/5. Probability of this one selection half, and here rate will be 7/10. Value is 3/10 plus 7/20. Just add these two, 6, 7, this is 13. 13/20 is the answer. Okay, I am changing the sum. I have written a red ball here. I am telling what is the probability of getting a white ball. This is a first part, you have done already. Second part is there. White ball probability you have to find. So you go by common sense. If you go by common sense, remembering formula also will be very easy. Number 2, you are going to do probability of white ball. Again, the same manner. First turn white from there plus second turn and white from there. What is that? Probability of first turn half. White, how many white balls? 2. Second turn probability half. White from there 3/10. So it will be 2/10 plus 3/20. 20 LCM, 4 plus 3. I hope you have understood the meaning of total probability. Okay, this case can be extended for 3 earns, 4 earns, any number of earns. We will find total probability this manner. Let us do one example here, or before doing that, let me ask you one question which find application of Bayes theorem here in our problem. Okay, that problem I am posing this manner. In the above problem, in this problem, one of the urn chosen randomly and a ball drawn from it. One of the urn chosen randomly and a ball is drawn. What is the probability of red? What is the probability of white? This you have understood. Now see the statement. One of the urn chosen randomly and a ball is drawn. It is found to be red. Find the probability of getting from the first term. See, the statement is changed. What we are going to find? One of the unchosen randomly, it is found to be red. Whenever in a problem found to be red, given to be red, happen to be red, all these things are given, you will proceed this manner. Okay? So, this, find the probability of getting it from the first turn. What? A red ball from the first turn. So, you are going to find what? You are going to find probability of red from first turn. How will I write this? Red from first turn. Because it depends on whether you have chosen 1 and 2 also. So this you write in the form P this by PR plus, you might have taken the second one also. Out of that, first one is coming. This multiplied by, wait a minute, because normally B1, B2, Bn and A are confusing in the sum. Which one to be taken as B1, B2, Bn? I just repeat that part, what we have written there. P Bi by A. B1, B2, Bn stands for what? B1, B2, Bn stands for the event which can B1, B2, Bn stands for those urns. I have written also already. And we are going to get probability of rate from first. So confusion point is there. Should I write P B1 by R or P R by B1? This you have to clarify. See, B1, B2, Bn, like those urns, one of them can occur. And probability what you are going to find? A rate. So the case is finding P B1 by R, not R by B1. I did a mistake over there. You are going to find P B1 by R. This is going to be P R by B1. This divided by that total probability PR by B1 PB1 plus PR by B2 PB2. Clear? So PR by B1 is what? Rate from this 3 by 5 half 3 by 5 into half plus 7 by 10 into half. So 3 by 5, half of getting cancelled, 10. So there will be 6 plus 7. Clear? So this will be 3 by 5, 10 by 13. 6 by 13. Clear? This is the answer. We can use Bayes theorem this way. I was supposed to cover till Bayes theorem with you. I hope you have understood. Next session, I will be solving graded sums from these topics. Okay? Before that, you go on practicing these kind of sums from your textbook. Thank you for staying with me.